Alright, so we just watched Lab 9 for, we have a little bit of time left over. I'll email you the information about it because like how the gentleman discovered, it's kind of cumbersome to watch certain portions of it on the video, so I'll email you the answers to those sections as well, and I'll email you which questions you're supposed to do as well. Alright, so go ahead and have your homework out, and let's go ahead and let's go over it. You had, for homework, you were starting in chapter 15 in that problem section, so I'll go ahead and check yours in a minute, gentlemen. It was chapter, I said 50, didn't I? I'm sorry. Wrong section because I'm in chapter 15 in physical science. It was chapter 8 for y'all. And it was problems 1 through 6 for that section. Alright, so problems. You were supposed to classify each of the following elements as a main group element, transition metal, or intertransition metal. If it is a main group element, tell whether it is a metal, non-metal, or semi-metal, and give the group name if there is one. This is a good review for your exam coming up, so it'll help you start thinking back a little bit and start rethinking of, okay, here's what the different terms are. Alright, who wants to start?
Sure.
Alright, Chris, what have you got for curium?
Wait, we're not doing 1 through 8?
Well, it's number 1, it's 8. What do you have for curium?
And
You're done? And is it a metal, non-metal, semi-metal?
I didn't have that.
Alright, write it down.
Yeah, because it said do that for.
Oh, okay, yeah, that's fine. Intertradition metal. So it is a metal. Alright, number B, or letter B, lead. Ethan. Alright, metal, semi-metal, non-metal. Metal. Alright, Rutherfordium. Alright, what do you got for that one? That's it. Alright, francium. We'll go back to Chris.
What was that, E?
It is D.
Main metal?
Good job. Do you remember what the special name for that group is? Well, technically it's a column.
What column's on?
It is in column number 1.
Alkali?
Good job. Alkaline metal. Number E, radon. What do you got, Ethan?
Main group.
It's
Non-metal.
Good job. What?
Noble.
Noble gas. Number F, gold. I keep saying number F, letter F.
Main group, non-metal, alkane.
It's transition.
You have it in the main group?
Transition.
Oh, I must have looked it wrong.
It's okay. Alright, so what group is that? Or like what section is that? Transition or intertransition? Transition, there you go. Alright, radium. So back over to
Main metal.
what do I?
Main metal.
Good job. And then it's in group 2.
Alkaline earth metals.
Good job. Alright, selenium, Ethan.
Main group, non-metal, chalcogen.
Chalcogens, good job. Alright, bromine.
Main group, metal, or non-metal, halogen.
Halogen. Alright, J, Chris.
Main non-metal.
Good job. Main group, non-metal. Alright, don't have any questions about that. Just kind of like a brief review. Alright, number 2. Write a balance equation showing an alkaline metal and an alkaline earth metal reacting with fluorine. So again, this is to kind of recheck out your balancing and to make sure you know what you're doing for it with the idea of alkaline metals versus metals. I'm going to blank that out so it's not quite as glaring on the screen. Alright, so for example, writing this out, what do you have for your balance equation? Anyone want to just give their answer because they think they got it right?
I don't think I got it. I just want to see if I did.
Okay.
You said it is random. It was just random, so. Because it didn't give us any of the, about.
Okay, so how many did you pick a alkaline metal just to use in your example?
I
What do you got?
K and F.
What was it? I'm just one.
2K plus 2F2. And arrow 2K F2.
Like that?
Yes.
Alright, you're super close but not quite. Alright, so you're right, and you can pick any alkaline metal, so
2. I had plus 2F2. On the left. 2F2. Plus 2F2. Yes, that's right. 2K plus 2F2. Arrow 2K F2.
That's right.
wow.
Looks right to me.
Alright, so for this one, alright, so we'll help you figure this out one for it. Alright, so you can pick any alkaline metal. Alright, so an alkaline metal has how many valence electrons? I mean, technically it's balanced, but it's not balanced correctly.
1.
Okay, so each alkaline metal wants to give off 1. It doesn't matter which one you picked. You could have picked any of them. So Ethan just picked K or potassium. That's fine. All right, fluorine starts with how many? 7. So fluorine needs how many to be happy?
1.
1. So each fluorine will take 1 for it. Alright, so if I combine potassium and fluorine, what's the ratio between them?
What's the ratio?
Okay, so we'll erase this away. I can know this. Alright, so potassium needs how, sorry, potassium wants to get rid of how many?
1.
Fluorine needs to take how many?
1.
So, do I need a second fluorine down there? No. So that's the reason why for that one. Is this one is just KF. So, this will help you fix that part because you can't have an extra fluorine down here. Alright, so, we'll erase this so we can fix it too as well. Alright, you are right that fluorine, there has to be 2 of them because 14 is a diatomic element. There always has to be 2 of them.
over there.
And then?
2 okay.
Yes. So that is the correct answer for it. So, you're right. You're right.
Close.
Yeah, you're right.
It's better than one before I just wrote some stupid.
It's okay, but again, like, you had the right idea of trying to balance it by putting a 2 here, so it looked correct, but your original formula was wrong. Alright, so does that help you out for it? Does anyone have any questions about this now? Does that make sense? Alright, anyone want to do the alkaline earth metal now? Another thing of, oh, I think I kinda get this now. Quentin! Alright, Quentin, what did you pick for your alkaline earth metal?
CA.
So calcium. Alright, so calcium wants to give how many?
2.
This one will give 2. How many will each fluorine take?
1.
1. So if I'm going to combine a calcium to a fluorine, how many do I need? 2 what?
2 fluorine.
Yeah. So if you see a F2, so that's where you got your idea probably from as well. Alright, so balancing this equation, what does it become? Or is it already balanced? It's balanced. Alright, do we have a question how to do this now? Alright, so that's the answer for those 2. Alright, for each of the following elements, predict both the combining capacity and the chemical formula of a compound with fluorine. Jimmy, the gentlemen were asking me about this on Friday, so to explain it to them, I'll explain it to you as well. Basically, the combining capacity is asking how many chlorines do you need for each of these elements, so it's a whole number amount. And then wants the compound for it as well. Like for example, radium starts off with how many electrons? Chris?
2.
2. And so if you're going to combine it, it says with chlorine. So I have, what is that I'm starting off with? Nope, not calcium. We're starting off with, alright, radium. Radium wants to lose 2, and so because of that, each chlorine can take how many?
2.
Each chlorine?
No, for 1.
1. So each chlorine can take 1. So how many chlorines do I need for each radium? 2. So the carrying capacity is 2, and then what's the formula?
RaCO2.
Yep. So that's the example for the first one. The gentlemen were asking me about what?
Actually, I know, right?
Good job. The gentlemen were asking about it on Friday because they were a little bit confused on it. So that's what the answer for. That's all it's asking for. All right. Anyone want to give the answer for iodine then?
Can I try?
All right, Chris. Ethan.
7.
You're right. So it starts off with 7. So.
And then no, I was looking at ICL.
ICL. All right. So keep in mind, if you have iodine and chlorine, what type of bond is that at the side now?
No, I have cobalt.
Covalent is correct. So because of that, they're both sharing. So how many? So iodine starts off with how many?
7.
And chlorine starts off with how many?
7.
So if they each share one of their ones with each other, will they be happy? Yep. So what's the ratio or the combining capacity between them? How many chlorines do I need to every iodine?
1.
1. So it's 1, and then it's iodine chloride or iodine chlorine. All right. Anyone have any questions about that one?
Almost got that right.
Do what?
Almost got that right.
Almost. All right. Letter C. All right. Anyone want to give their answer for it? All right, Quentin. Thallium.
3.
All right. So 3.
3 RaCO3.
That is it. Exactly.
I had that.
You had it? Good. All right. Anyone have any questions about how to solve this one?
Okay.
All right, Chris. Last one for you. Tellurium.
Choose TeCO2.
Good job. All right. Anyone have any questions about how to solve this? So again, once you get it, you got it. All right. So give the number of valence electrons. Number 4 should have been really easy. Give the number of valence electrons found in atoms of the following elements. This should have been real easy and real straightforward. What?
I think I built this one.
Oh, really? Oh, okay. Potassium. How many valence electrons?
2.
Alright, hydrogen.
1.
Good job. Cl is what as a side note as an element? So I've been saying it, but you also need to know the element names. Chlorine, and then how many? Yeah, D, how many valence electrons?
7.
Good job. Alright, S, what is that?
Sulfur.
Good job, how many valence electrons?
7.
Ooh,
8, 6.
6.
I was in the wrong one.
It's okay. Alright, number C. Well, I'm sorry, letter F, C. It is carbon. 4. Alright, G, back over to you, Chris.
3.
Alright, and what element is that? Al. Aluminum. Alright, we have a question about how to solve that? It should have been real easy. Alright, number 5, give the Lewis symbol for each of the following elements. So this is Lewis symbol, not Lewis structure. So Lewis symbol is what, Ethan?
Dots.
Yep. So again, this should have been a really easy section again. Just saying, oh, okay, I'm going back and remember this. So magnesium, what do you got?
2 dots.
Yeah, it doesn't really matter where you have them. Alright, OS, how many dots?
2.
Yep. FR, what do you, how many dots?
1.
That's it. V, how many dots?
2.
Alright. Phosphorus, nope, that's potassium. Nope, that's phosphorus. How many dots?
5.
That's it.
4.
Alright, wait, come here. Alright, E, how many?
4.
Alright, and then zinc.
2.
Alright, anyone have any questions on how to solve that? Again, real straightforward. Alright, the last part was probably the hardest part, honestly, as you were going through this. Tell which member of the following pairs is larger and give the reason for it. So remember, if you're looking at the periodic table, which corner, top left, top right, bottom right, has the larger atoms? Bottom left. Because remember, as you go down the periodic table, the energy level is increasing. So remember, like 1s1, 2s2, 3s2, you're going down on the periodic table, the higher energy layers there are. So they're getting larger and larger. As you go across, like if you're looking on the same group, yes, no, if you're looking on the same period, if you go across, which one's larger, metals or non-metals? Ethan, which one's larger?
Middle.
Why? You're right, but why?
Because it's closer to the left side. Alright.
Still right, but why? Alright, so who wants their electrons more? Valence electrons, non-metals or metals?
Non-metals.
Non-metals. So, even though it's in the same layer, they're going to pull them in slightly closer towards them. So that's the reason why, even if you're looking on the same period, the metals are slightly larger than the non-metals, because the metals pull them in just slightly closer towards them. Alright, so that's the basics starting off for it, and then it starts looking at cations and anions as well. Alright, letter A, Chris, which one is larger and why?
AR.
Why?
It's further right.
Alright, so what did we just say?
I know it's wrong.
Okay, so you can fix it, so which one's larger?
I don't know what the other one was.
Aluminum. And so you're right because it's farther to the left. So you have the right idea, you just flipped it in your head. Alright, letter B, F and KR. Alright, Ethan,
F.
why?
It's closer to the left side.
Alright, so looking at it though, KR is it in the same energy level though? No. So you have F, I'm sorry, I
On
didn't get this.
KR.
Alright, KR and then F.
No, it's not in the same.
So which one has more layers or more shells?
KR.
KR. So the first thing you want to look at is you're right, it's farther over to the right, but it's so far down that energy layers or circles, to put it this way, it trumps going farther to the right for it. So you only look at right and left if you're in the same layer. So if you're looking at fluorine, fluorine has how many layers?
7.
You're thinking of valence electrons. How many? Let's see. How many layers is it? What line is it on?
1, 2.
2. So it has 1 layer, 2 layer. Krypton has how many layers?
4.
Good, I didn't actually count them. 1, 2, 3. Should have been more space. Alright, which one's larger? Krypton. Alright, so does that help you out for it? Alright, we will finish going over this tomorrow. Alright, your homework for tonight, finish the lab. And then looking over for chapter number 7 now, working our way backwards slowly for it. So we looked at chapter 8, we looked at chapter 9, chapter 7, going back a little bit further. Alright, you're going to do 1 through 15 odd, so it'll help you out, 1 through 15 on page 112, the chapter 7 review, 1 through 15 odd. Alright, have a good afternoon.